Welcome back. We are discussing a few topics under environmental engineering. In this video, we'll discuss about the removal of some miscellaneous impurities. The first one is removal of iron and manganese. Iron and manganese, when they are present in water, they are going to cause colored stains to the clothes or some other material. And to remove this, we go for aeration process. Let us look at the aeration process. Aeration process is nothing but the exposure of this water to oxygen. So first of all, let us look at this process here. Air contains oxygen, and the concentration of oxygen in the water depends on the temperature. There is going to be a saturation concentration at a particular temperature. For example, at 20 centigrade, the saturation concentration of water, oxygen in the water is around 9.2 milligrams per liter. If the concentration of the oxygen in the water is less than that at that temperature, then automatically what will happen is it can take oxygen from the air, because this is the concentration available is less than the saturation concentration. If the concentration in the water is more than the saturation at that temperature, maybe 10 or 10.5, so that means it can release some amount of oxygen. So releasing is desorption, taking from atmosphere is absorption. This is a continuous process, it keeps on going. But the only thing is, everything happens at the point of interface. This is air, this is a liquid interface. Because what will happen, if the oxygen is in the gaseous form, it should mix with the liquid in the water. So ultimately what will happen is the barrier is nothing but the liquid interface. So here the gas cannot be easily accepted by the water, and from the water it is not easily converted back into the air. That means the gaseous form. So there should be a breakage of this interference at the interface. For that we need to provide some turbulence. So that turbulence we have to provide. So how we are going to provide turbulence? By mixing, first thing is, but maybe by changing the inertia of the flow of the water. For example, you see in this particular case, the water is flowing from one step to other step. Here potential energy is converted into high kinetic energy. So the velocity of the water is more. By going through the fundamentals of fluid mechanics, the velocity is more means the flow is changed from laminar to turbulent or transition. Laminar flow means low velocity. Turbulence means high velocity. More and more velocity is created, more and more turbulence is created. More and more turbulence is created means more and more is the breakage of that interface between the liquid and the gas. So we want to break that interface, we create a turbulence. For that we are doing all such type of things. So at any point of the time, the rate of concentration dC by dt is proportional to whatever the concentration is left in the liquid. So higher concentration, lower concentration, always the flow is moving towards that, right? So we are not bothering so many things. We are only bothering about absorption and desorption, accumulation of oxygen from the air. So when something is exposed to air, that means it can easily get oxidized. So you can see there are different forms where the water can be exposed to air, and subsequently the turbulence is also can be very quickly created at the point of interface. So now is a stepped cascade, we call as a cascade towers, a cascade aerator. So this is a sprinkler. This is another cascade tower. So at this point, we are having high turbulence because high velocity is there. So we are using this iron and manganese in this method. When iron and manganese bearing water is exposed to our air, they will get oxidized to their corresponding oxides. So in the oxides, they will be insoluble state. So they will be easily removed when they're undergoing settling in the subsequent stages. So oxidation of iron compounds can also be obtained by chlorination followed by sedimentation and filtration. You can see here, this is the impact of the iron or the manganese bearing water. It will give colored water. So they cause reddish brown stains to the water. Color, odor, and taste removal from water. So let us quickly see the causes for these problems. They are caused due to organic and vegetable matter. They will get dissolved in water and they will creating color. Dissolved gases, give carbon dioxide, methane, etc. there. And dissolve in water. They will, for example, carbon dioxide will get converted to carbolic acid. So automatically it will give you bad taste, acidic taste is there. So now you can see in any water bodies, there will be a number of offering, floral offerings will be there, and the fruits will be offered. And here you see a lot of dirty material is stacked here, and the same water we are using the animal washings, the dirty material from the skins of this animal, they will get moving along with the water here. And there is a possibility that industrial or domestic wastewater is now coming out and joining into some streams at some point of the time. So there may be colored wastewater. They give some color and bad smell also to that particular water. So methods for removal. There are possibility for by activated carbon using copper sulfate, potassium permanganate, chlorination or ozonation, coagulation, followed by filtration. So let us see the activated carbon treatment. Activated carbon treatment will remove the impurities which are causing color, odor, and taste by attaching to the surface of the activated carbon, adsorbing to the pores of that adsorbent. It all depends on how much is the dosage of activated carbon and how much contact time we have to maintain. That they will be determined using the laboratory test. So it can be applied directly as a powder or through a fixed bed filter. The sand bed, the carbon can be applied as a sand bed type of filter medium, or you can spray the carbon as a powder on this. Filter beds are usually more effective. The activated carbon, it can be applied to the raw water before treatment and to the mixing chamber along with alum. It can be applied after coagulation just ahead of the sand filter. So there are different possibilities when you are adding this. These problems, the odor and taste problems, they can be removed. The copper sulfate addition is available in powder or in crystal form. It can be applied either directly in the distribution pipes or in open reservoirs. Copper sulfate is converted into solution at the rate of 0.3 to 0.6 ppm by mixing it to water, normal water, and added to this raw water. Add in distribution pipes. Copper sulfate is sprinkled in powder form on water surface in the reservoirs. If it is a problem in the reservoirs, these bad smells, then it can be sprinkled. The copper sulfate can also destroy a variety of microorganisms. The chlorination or ozonation methods. Adequate amount of chlorine added to this water will remove color or taste and odor. So usually this is a process used to remove all such type of bad smells. At higher concentrations, usually we are calling it as a superchlorination. This is normally adopted during epidemics. So we used to add a concentration higher than the normal practices of chlorination to remove all such type of unwanted organisms. Bad taste may be imported to the water. Higher concentrations may give bad taste. So that should be removed by dechlorination. Chlorine dioxide is effective for removing phenolic and algae waste. Ozonation can improve the appearance of water by removing traces of colors and odors. For a higher dose, it may impart earthy taste to the water. So for all these things, what you can understand is, so we have to conduct some laboratory test to see how much should be the dose, how much should be the contact time, what should be the operating parameters to have the removal of color, odor, and taste. But there's a possibility that there are a number of options are available to remove these problems in the water. Some other methods are potassium permanganate can remove taste produced by microorganisms. It can also be used alone or in combination with chlorine. It is effective in removing taste and odors caused by different impurities. And this is available in even powdered form, right? So these are some of the methods for removal of some impurities in the water. Okay, thank you.